The Sahara Desert is one of the harshest places on Earth. With its scorching heat, freezing nights, and relentless dust storms, life here isn't just difficult, it's nearly impossible. Farming, in particular, seems unthinkable. After all, how can crops grow in a place where water is so rare? But something unexpected is happening. Across parts of the Sahara's southern edge, strange crescent-shaped pits are beginning to appear. They're known as half-moons, and they're transforming this barren landscape in ways few imagined possible. Where once there was only dry, cracked earth, greenery now spreads. Trees, shrubs, and crops are beginning to grow, even though no one waters them. How is that even possible? Let's find out. To understand what's going on, we need to talk about something most of us rarely think about: soil. In 2006, scientists estimated that about 25% of all life on Earth was linked to soil. But in 2023, that estimate was revised. New research revealed that nearly 59% of Earth's species live underground. That's more than half of all known life, beneath our very feet. Soil isn't just a dirty mass. A single teaspoon contains more living organisms than there are people on Earth. It's home to fungi, bacteria, insects, and worms, forming a complex and delicate web of life. For example, over 90% of fungi species and 85% of all plants are connected to this underground ecosystem. But soil isn't just a living habitat. It's the foundation of our food system. Roughly 95% of the world's food supply, fruits, vegetables, and grains, depends on it. If the soil fails, our ability to grow food collapses. That's why healthy soil is not just important, it's vital for human survival. And there's more. Soil also acts as a filter for water. As rain seeps through the ground, microbes and minerals clean it naturally, making underground water sources some of the safest to drink. Plus, soil is the planet's largest carbon sink on land, second only to the oceans. It captures more carbon than all land plants combined. Unfortunately, this crucial resource is disappearing. Today, nearly 30% of the Earth's soil is degraded, damaged by overfarming, deforestation, and climate change. If we don't act, that number could climb to 90% by 2050. Without healthy soil, food becomes scarcer, water becomes harder to store, ecosystems collapse. But in one of the world's most fragile environments, a country on the edge of the Sahara, people have found a remarkably simple solution. Let's travel to Niger, where this battle is unfolding. Niger is a landlocked country in West Africa. Of its 23 million people, nearly 17 million depend on farming for survival. They grow crops like millet, sorghum, cassava, and cowpeas. Many also raise livestock such as camels, goats, and cattle. But Niger faces a serious challenge. Around 80% of its land is swallowed by the Sahara. Daily temperatures can soar to 104 degrees Fahrenheit 40 degrees Celsius, only to plunge below freezing at night. Winds whip across the dunes, carrying choking clouds of dust. That's why most farming happens in the southern regions near the Nigerian border, where the land is semi-arid rather than pure desert. This region receives between 12 and 24 inches of rain per year. It's not much, but it's just enough. Or at least, it used to be. Thanks to climate change, rainfall has become increasingly unpredictable. Sometimes, an entire season's worth of rain falls in a single storm. Then comes nothing, for weeks or even months. This pattern creates chaos. During long dry spells, the soil becomes so compacted that when rain finally comes, it can't absorb it. The water just runs off, taking topsoil and seeds with it. And then the cycle of drought begins again. Meanwhile, the Sahara is creeping southward. Every year, it claims more farmland. Faced with these challenges, farmers in Niger began turning to a traditional, yet surprisingly effective method: the half-moon pit. The idea is simple but brilliant. Farmers dig crescent-shaped pits into the ground, each shaped like a bowl that opens uphill. When it rains, the half-moons trap the water, preventing it from flowing away. Instead, the water soaks deep into the soil, creating pockets of moisture that persist long after the rains have gone. Each pit is dug by hand, using a traditional tool called a debia. It's grueling work. A single half-moon can take hours to complete. A typical pit ranges from 6 to 26 feet in diameter, with a depth of 12 to 20 inches. Preparing a 2.5-acre field can take 2 to 4 months of manual labor. But Niger's farmers aren't backing down, because the results are extraordinary. Once the pits are in place, seeds are planted inside, sometimes alongside compost or manure to kickstart fertility. When rain arrives, the water stays put. Soon, the first green shoots appear. Shrubs, crops, and grasses begin to grow. As they take root, something amazing happens. The plants attract termites and other organisms that begin breaking down organic matter in the pits. This creates rich humus, improving the soil and helping it retain even more water. With every season, the land becomes greener. At first, only the inside of the pits turn green, but over time, as moisture seeps into the surrounding ground, plants begin growing between the pits too. Eventually, entire fields that once looked like desert turn into thriving green landscapes. Some areas have transformed in just 4 years, but the benefits don't stop with crops. These small oases of greenery have another surprising effect. They cool the air. When plants perform photosynthesis, they release moisture into the atmosphere, a process known as transpiration. This moisture can create clouds, cool the area, and may even trigger local rainfall over time. Scientists believe that with enough vegetation, these green zones could influence regional weather patterns. It's an idea still under study, but one with incredible promise. More importantly, the half-moon technique has proven that ordinary people, using basic tools and traditional knowledge, can fight back against the desert. But they're not fighting alone. Niger is part of a much larger movement, the Great Green Wall of Africa. This massive initiative involves 20 countries across the continent, all working together to stop the Sahara's advance. The goal? To create an 8,000-kilometer belt of vegetation stretching across the entire width of Africa, from Senegal in the west to Djibouti in the east. The idea isn't just to plant trees, but to restore degraded land through sustainable farming, pasture creation, and ecosystem recovery. And yes, half-moons are a key part of that strategy. Progress, however, is mixed. By 2019, only 15% of the wall was completed. As of 2024, that number has reached just 30%, with a target date of 2030. Time is running short, but in some countries, efforts are ramping up. Senegal has planted over 11 million trees. Nigeria has restored more than 10 million acres of degraded land. Ethiopia is leading the charge, with an astonishing 37 million acres restored and 5.5 billion trees planted. Other nations, like Chad, have made more modest progress, just 1.1 million trees. But even these gains are under threat. One of the biggest dangers comes from desert locusts, huge insect swarms capable of devouring entire fields in a matter of hours. A single swarm can contain hundreds of millions of insects, and once they move through an area, the vegetation is gone, leaving behind only dust and devastation. On top of that, some regions along the wall face instability from armed groups. These factions aren't interested in climate projects. They have their own goals, often violent and destructive. In such areas, environmental work grinds to a halt. And yet, despite all this, the Great Green Wall remains one of the most ambitious ecological projects ever attempted. What makes the story of Niger and the half-moon so powerful is that it's not driven by billion-dollar budgets or high-tech solutions. It's powered by people, by farmers digging with hand tools, by communities determined to reclaim their land. They're not just restoring the soil, they're restoring hope. In a time when climate disasters dominate the headlines, the transformation of the Sahel offers a rare example of what is possible. What begins with one pit in the sand can become a field. What becomes a field can spread into a forest. And what becomes a forest might just change the climate. All it takes is patience, persistence, and one half-moon at a time. When you think of deserts, you probably don't think of fish. And yet, Egypt, a nation where much of the landscape is dry, sandy, and sun-scorched, produces more fish than any other country in Africa. In 2023 alone, Egypt harvested an impressive 2 million tons of fish, with both a Mediterranean and Red Sea coastline. That might not sound surprising, but here's the twist. About 80% of that fish doesn't come from the sea. It comes from the desert. Yes, the same desert known for its barren dunes and scorching temperatures is now home to millions of fish. So how exactly did Egypt manage to pull this off? Let's start at the beginning. On the shores of the Mediterranean, Egypt's Mediterranean coastline stretches around 650 miles, and for decades, it was a major fishing zone. Between 1920 and 2019, nearly 3.8 million tons of fish were pulled from Egypt's Mediterranean waters. Sardines, once a major part of the national catch, dropped from 30% of the total haul in 1950 to under 4% by 1968. Why? Overfishing. And then came another major disruption. The Aswan High Dam, completed in the 1960s. While it brought electricity and helped control floods, it also blocked nutrient-rich silt from flowing into the Mediterranean. These nutrients were essential for sustaining marine ecosystems. Ironically, in the 1980s, fish populations made a brief comeback thanks to agricultural runoff. Fertilizers flowing into the Nile created nutrient-rich waters that helped fish stocks rebound. But the boost was temporary. By the 2000s, catches began falling again. Between 2011 and 2019, they plunged nearly 50%. Research showed a troubling pattern. Every time an area's fish stocks ran low, fishermen moved on to another spot. This cycle eventually reached a dead end. With international waters off limits and Egypt's own coastal fisheries depleted, the Mediterranean could no longer provide what the country needed. To the east, Egypt also has access to the Red Sea, with another 620 miles of coastline. But the outlook there is just as bleak. Scientists studying 55 commercial fish species in the Red Sea found that 91% were overfished. And with other coastal nations controlling their own waters, Egyptian boats couldn't expand outward. Geography, politics, and environmental limits had all closed in. Even worse, open sea fishing is unpredictable. Fish migration patterns shift with ocean currents and temperature changes. That level of uncertainty doesn't work for a country like Egypt, where food security is a national priority. Faced with failing sea fisheries and a growing population, Egypt looked for alternatives. And that's when the desert came into focus. As odd as it sounds, fish farming in Egypt's desert started way back in the 1930s. Early experiments introduced carp into artificial ponds on research farms. The effort was small, but it planted a seed. In 1961, Egypt took a major step forward, building a 296-acre fish farm in the eastern Sahara. Over the next 2 decades, the government invested heavily in aquaculture. By the mid-1980s, Egypt had 4 large hatcheries, 6 farms, and 5 fry collection stations. Annual output had nearly tripled, reaching 45,000 tons. But things didn't stop there. The real transformation came decades later, with massive projects like Al Fus and Birkut Galleon. Near Port Said in the Nile Delta lies Al Fus, one of the world's largest desert-based fish farming complexes. From space, the site is hard to miss. Nearly 6,000 fish ponds carved into the sandy earth. Among them are over 300 freshwater ponds, fed by reverse osmosis systems that convert salty desert water into fresh water. The on-site plant produces around 198,000 gallons of fresh water every day to support these operations. But Al Fus is more than just a cluster of ponds. It's a self-sustaining aquaculture ecosystem, complete with a sorting and packaging plant handling 8 tons of fish daily, an ice factory producing 40 tons of ice per day, a feed mill that produces 6,000 tons of fish food annually, recreational lakes spanning over 6,000 acres. It's even a hub for scientific research. In-house laboratories work on breeding red tilapia, a salt-tolerant version of the freshwater favorite. Once perfected, this innovation could eliminate the need to convert salt water at all, saving time, energy, and water. When the farm first launched in 2021, it produced 460 tons of fish. Today, it's producing over 5,000 tons, with targets set at 12,000 tons by 2026. To the west of the Nile Delta, another massive facility, Birkut Galleon, has taken root, covering 3,950 acres. It contains over 1,300 fish ponds and its own incubator for 20 million marine fish fry. The industrial area spans 55 acres and includes a fish processing plant with a 100-ton daily capacity, a feed factory that can produce 180,000 tons per year, an ice production facility for cold storage needs. Launched in 2017, Birkut Galleon produced 13,800 tons of fish annually in its first phase, and production has continued to grow. Here's the part that surprises most people. Even with these massive state-run facilities, the majority of Egypt's fish still comes from small farmers. Roughly 86% of Egypt's total fish production is the result of private individuals and families operating small fish farms throughout the country. Many of these farms are clustered along the Nile, where conditions are more favorable. Others are scattered across the desert, using portable pools, repurposed materials, or even greenhouse aquaculture systems to raise tilapia. In some of these setups, advanced methods like smart greenhouse aquaponics are used to conserve water and improve efficiency. This is critical in a country where water is more precious than gold. Egypt is one of the most water-scarce nations on Earth. Over 97% of its water comes from the Nile, and even that isn't enough. The country faces an annual water deficit of 1.8 trillion gallons. Each citizen gets about 148,000 gallons per year, which is far below the global water poverty line of 264,000 gallons. Yet fish farming is water intensive. So how does Egypt make it work? The answer lies in recycling. Water used in fish ponds, though filled with organic waste, can be redirected to irrigate crops. The plants absorb nutrients from the waste, cleaning the water in the process. That water can then be sent back to the fish ponds, creating a closed-loop system. Across Egypt, farmers have built networks of canals linking their fish ponds to nearby fields. The result is more food, using less water. Despite its success, Egypt's aquaculture industry faces hurdles. One unexpected issue comes from the very top: government competition. When Egypt launched state-run megaprojects in 2015, it also slashed the budget of the General Authority for Fish Resources Development, the agency supporting small-scale farmers, from $8 million to just $2.5 million. Many small farmers now say they feel neglected or even threatened by the government's growing dominance in the market. Still, Egypt's desert fish farms are not just about solving hunger. They're also about building resilience and even profit. Projects like Alphus and Birka Galleon are attracting global attention, and Egypt could one day export these technologies to other arid nations facing similar challenges. When we think of restoring degraded lands in the United States, we often imagine massive government programs, expensive technology, or years of painstaking manual labor. But surprisingly, one of the most powerful forces in land restoration has buck teeth and a flat tail. That's right, beavers. Before we dive into how these incredible creatures are transforming landscapes, let's start with the basics. One of the biggest reasons land becomes barren and unusable is soil degradation. Over time, overgrazing, deforestation, and poor farming practices wear down the soil until it can no longer support crops or even native vegetation. But not all hope is lost. Across the country, new strategies are being tested to heal the land and make it fertile once again. One of those strategies, controlled grazing. It's a way of rotating livestock between pastures to prevent overuse and allow grasses and roots to recover. Another method gaining attention is letting nature's engineers, the beavers, do what they do best: build dams and shape ecosystems. At first glance, beavers might seem like ordinary woodland critters. They gnaw on trees, slap their tails, and build dams. Cute, but nothing special, right? Wrong. What they do has massive ripple effects. Their dam-building instincts help store water, create wetlands, support wildlife, and even reverse environmental damage caused by humans. Take Arizona, for example, a state better known for its cacti and scorching deserts than for lush wetlands. But not long ago, something remarkable happened in a part of Arizona that had been degraded for generations. And it all started with the quiet return of a few humble beavers. Let's rewind the clock. Centuries ago, before European settlers arrived, North America was beaver country. From the frigid coasts of Alaska to the marshes of the Gulf of Mexico, beavers thrived. They shaped the landscape, carving out rivers and wetlands with their dams, creating rich, biodiverse environments. But then came the fur trade. Beavers had the misfortune of having incredibly valuable pelts. Their fur was warm, waterproof, and perfect for making hats and coats. Their castoreum, an oily substance secreted near the tail, was also highly prized for perfumes and medicines. And so began a ruthless hunt. In the early 1600s in New Netherland, a Dutch colony on the east coast, it's estimated that 80,000 beavers were killed every year, for 9 straight years. In Connecticut and Massachusetts, over 10,000 beavers were trapped annually between 1620 and 1630, and by 1670, companies like the Hudson's Bay Company were shipping countless beaver pelts from Canada to England. The East Coast was quickly emptied of beavers, and hunters pushed westward. From 1806 to 1838, just 3 decades, beaver populations across much of the U.S. and Canada were nearly wiped out. The once abundant species teetered on the edge of extinction. One of the ecosystems that suffered most was the San Pedro River in southern Arizona. This river flows through the Sonoran Desert, a region known for its arid climate, extreme temperatures, and limited rainfall. But before the beaver hunt began, the San Pedro was something extraordinary. It was an oasis, a winding, life-giving stream surrounded by swamps, meadows, and vibrant forests. Beavers built sprawling ponds that supported fish, birds, and countless other species. In fact, early settlers were amazed by the sheer number of beavers. They dubbed the river Beaver River. But that didn't save the animals. Beavers were trapped en masse. And then came a fatal blow from an unlikely source. In the 1920s, the U.S. military got involved. Soldiers stationed at Fort Huachuca, located near the San Pedro, dynamited beaver dams to prevent stagnant water from becoming a breeding ground for mosquitoes, which they believed caused malaria. The destruction was devastating. The beavers disappeared, and so did the wetlands they had built. Over time, the San Pedro began to dry up. Without dams to hold water, the river lost its floodplains and wet meadows. Vegetation vanished. Birds stopped migrating there. Wildlife populations dropped. By the 1950s, the river only flowed during Arizona's brief rainy seasons. The once lush river corridor had become just another dry desert wash. And that's how things stayed for decades, until the late 1990s. When scientists, ecologists, and conservationists asked a radical question: what if the solution to restoring the San Pedro wasn't building artificial dams or launching million-dollar restoration projects, but simply bringing back the beavers? From 1999 to 2002, the idea was put to the test. A small group of beavers, just 19 individuals, was reintroduced to the river in Cochise County, along a stretch of the San Pedro. What happened next was nothing short of miraculous. By 2006, researchers counted over 30 dams built by the beavers. These weren't just piles of sticks, they were mini ecosystems. The dams slowed down the river's flow, which allowed water to spread out, seep into the ground, and refill underground aquifers. Ponds formed, wetlands returned, and with them came life. Birds began to reappear in numbers not seen for decades. Fish and insects flourished. The willow flycatcher, an endangered bird that had all but vanished from the region, returned to nest in the newly formed wetlands. Scientists monitoring 13 species of birds found a staggering 50% increase in population density in areas where beavers were active compared to areas without them. Beavers weren't just surviving, they were thriving. Some wandered away from the original release site. One intrepid adventurer was nicknamed the Surfing Beaver after drifting dozens of miles downriver to the Gila River. Others made their way to remote canyons or crossed the border into Mexico, where they started new colonies of their own. By 2009, the population had grown to somewhere between. In 2008, a massive flood hit the San Pedro. Unlike human-built dams, beaver dams are made of sticks and mud. They don't stand a chance against powerful floods. After the waters receded, researchers couldn't find a single dam. It looked like all the work had been washed away. But nature had a surprise in store. Just 1 year later, the beavers had rebuilt. By 2009, 30 new dams stood proudly in place. It was clear, the resilient wetlands and the green corridors snaking through the desert. And perhaps the most powerful lesson of all: sometimes, the best way to fix what humans broke is to let nature do the work. Beavers, with nothing but instinct and wood, managed to transform a nearly lifeless desert stream into a flourishing habitat. In a time when climate change, water scarcity, and habitat destruction loom large, their story offers hope and a blueprint for how we might reclaim other damaged lands across America. All it takes is a few rodents and a whole lot of sticks. This is Australia. You probably knew that already. But what you may not know is that, until recently, Australia held a unique title. It was the last major honey-producing country in the world that remained free of the varroa mite, a tiny but devastating parasite, and the greatest threat to honeybees globally. That is, until the summer of 2022. That's when everything changed. It began quietly. A single detection in New South Wales, near the port city of Newcastle. But in just a few short months, the situation spiraled. The government scrambled to contain the spread, and beekeepers were forced to make devastating sacrifices. Over 28,000 beehives were destroyed across. And here's the thing. Many of those hives weren't even infected. They were part of pollination operations, sent into farms to help fertilize crops. But once the mite was detected in the area, all hives, infected or not, were destroyed without exception. Once introduced, it spreads like wildfire. By the time the threat was understood, it was too late. Many infected hives had already returned home or continued to other locations, carrying the mites with them. The result? Rapid spread across New South Wales, including outbreaks in Coffs Harbour and regions bordering Victoria. But mites don't fly. So how do they move? When an infected hive weakens or collapses, nearby bees often rob it for honey. And when they do, the mites seize the opportunity, hitching rides back to new colonies. Even modern beekeeping practices, like placing hives close together, create the perfect storm for infestation. Eventually, authorities had to face the facts. Eradication was no longer realistic. Despite spending over $100 million on the effort, containment failed. In 2023, the Australian government officially pivoted from eradication to management. Beekeepers were advised to adapt to the presence of the mite and prepare for long-term coexistence. For many, this was devastating news, especially when considering that all the previously destroyed hives, perhaps hundreds of millions of bees, may have died in vain. Still, it's not all doom and gloom. There's hope in science and in nature. Some honeybees have evolved resistance to the varroa mite. These bees practice what scientists call varroa-sensitive hygiene. They detect mites in the brood cells and remove the infected larvae before the mites can reproduce. Others groom each other and chew off the mite's legs. These traits are genetic and could be the key to survival. The challenge: most commercial bee colonies don't have these behaviors, and even if they do, they're often less productive in terms of honey output. As a result, beekeepers have historically bred for yield over resilience. But that might have to change. Researchers are now developing artificial insemination techniques and selective breeding programs to encourage mite-resistant traits in bee populations. It's not an overnight solution, but it's a long-term path to coexistence. There's also a surprising twist to this story: native bees. Australia is home to more than 2,000 species of native bees. These insects are incredibly diverse. Some are stingless, others solitary, some tiny, some metallic in color. And they've existed on the continent for millions of years without any need for imported European honeybees. Now, with the spotlight on pollinators, native bees might finally get the recognition and protection they deserve. Ironically, the mite's invasion could offer native species a second chance. With the decline of honeybees, native bees may become more important to both agriculture and ecosystems. In time, they could fill some of the pollination roles left vacant by declining honeybee colonies. So where does this leave us? The arrival of the varroa mite in Australia marks the end of an era and the beginning of a new one. Beekeepers, scientists, and farmers are all adapting to a changed landscape. The goal now is not elimination, but adaptation, to find a way forward that protects bees, secures food production, and preserves the fragile ecosystems that depend on pollination. Because in the end, this isn't just a story about bees. It's a story about us, and whether we can respond to threats not just with force, but with understanding, cooperation, and innovation.